Topic for our today's discussion is Hydel Energy. Hydel Energy is a form of renewable energy. The working principle is based on conversion of potential energy of stored water into rotational kinetic energy of turbine. A large dam is built across a river and this acts as a large reservoir of water. From the reservoir, the water is drawn periodically by opening and closing of floodgates, also called sluice gates. The water travels through the penstock and falls on the turbine blade with high kinetic energy. This causes turbine fan to rotate. The shaft connected to the turbine is connected to the generator at other end. This generator converts high rotational kinetic energy into electrical energy. This energy is later supplied to the households.
Now coming to the turbines used in hydropower plant. Mainly there are two types of turbine, namely impulse turbine and reaction turbine. Pelton turbine, which comes under impulse turbine category, is most widely used in hydro energy production. A typical Pelton turbine looks like as shown. At the center of Pelton turbine, a shaft is present which is fixed with the help of bearings. At the circumference of the Pelton turbine, the blades are uniformly distributed and they all look alike. These blades are also known as buckets. The whole assembly is made such that the water falling on turbine blades is in tangential direction. The high-speed water jet is ejected through nozzle, and when this jet hits the bucket of the Pelton wheel, this induces impulse force. This force makes the turbine rotate. In short, the Pelton turbine transforms kinetic energy of water jet to rotational energy. The rotating shaft runs the generator and produces electricity. A cut is provided at the end of the water bucket to ensure no interference of the water jet with other buckets. Buckets are casted a single solid piece in order to avoid fatigue failure. The water jet is split into two equal components with the help of a splitter which is present at the middle of the bucket. The special shape of the bucket makes the jet turn almost 180 degree. The blade out angle usually used is around 180 degree. Now coming to the Pelton wheel analysis, we can see that the energy transferred is based on purely kinetic energy, therefore it is called impulse turbine. From the Newton's law, we can say that force of impulse is given by rate of change of momentum of the velocity jet of the water. The power extracted is the product of impulsive force to the velocity of the bucket. If the pattern wheel buckets are held stationary, then even if there is huge impulsive force, power extraction will be zero. Similarly, if buckets are moving with the speed as jet, then also the power extraction will be zero. In short, the power extraction is zero both at zero bucket speed and when the bucket speed is same as the jet speed. The maximum power extraction happens when the bucket speed is half the jet speed.
Now coming to the velocity diagram of turbine, there are some various symbols used. CB denotes blade velocity, CAE denotes exit absolute velocity, CRI denotes relative velocity at inlet between rotor blade, CRE relative velocity at outlet, CAI inlet absolute velocity, delta CW denotes tangential component of difference of velocity, alpha I denotes nozzle angle, alpha E is the angle made by absolute velocity and blade velocity at exit. Beta E and beta I are the blade angle. Force on the fluid is given by m dot times minus CAE cos alpha E minus CAI cos alpha I, which is in short rate of change of momentum in tangential direction. Force on the blade is given by m dot times delta CW. Rate of work done on wheel is given by force on the blade times blade velocity. Energy supplied per unit mass is given by CI का whole square by 2. Ratio of rate of work done on wheel and the energy supplied per unit mass gives us efficiency of turbine. Now coming to the electrical power generation part. As the water falls on the turbine, the shaft connected to the turbine rotates. Shaft's other end is connected to the coil, which is kept between two strong magnets. As the shaft rotates, the coil also rotates and the magnetic flux passing through the coil changes with time. According to the Faraday's law, when the magnetic flux linking a circuit changes, an electromotive force EMF is induced in circuit proportional to the rate of change of flux. There are some losses also in hydropower plant. First one is viscous losses. Viscous losses happens because of the friction, turbulence in nozzle because of the high velocity of the jet, reduction in enthalpy available in the nozzle because of the friction, and the leakage losses because of the leakage of the water. There are some other losses also. So that was all for this.